First, what is differentiation? Differentiation is a method of finding the derivative of a function. It is also a process where we find the instantaneous rate of change in function based on one of its variables.
Assalamualaikum warahmatullahi wabarakatuh. In this video, we will explain about the application of differentiation. Regarding to our test video that was given, application of differentiation is the concept of differentiation calculus center on the derivative, which is an outcome of any slopes of tangent. In this application of differentiation, we can show that application of derivative in solving problem is involving the related rates, analysis of functions, applied of max and minimum problem, Rolle's theorem, and mean values theorem. So first, what is analysis of function is used for? Analysis of function 1 is graph of the polynomial function. Secondly, analysis of function 2 is rational function. The second application of derivative in application of differentiation is applied of max and minimum problem. Applied of max and minimum problem is solving max and minimum problem using first and second derivative test. Next, the third application of differentiation or solving problem is related rates. Related rate is the rate of change associated with two or more related quantities that are changing over time. Lastly, Rolle's theorem and mean value theorem. Rolle's theorem has their own formula that we use to put our value in that formula.
Next, what is applied maximum and minimum problem? As we know, maximum and minimum is important to solve our problem. Maximum is the highest value, while minimum is the lowest value. So, to identify the maximum and minimum, we need to apply the second derivative test. If the value is less than 0, then it is maximum. But if the value is greater than 0, then it is minimum. The next point is step of solving the differentiation. There are 4 steps to do. The first one is draw the diagram. It is necessary to draw the diagram in order to identify the info. Second, find the derivative test. In this step, we need to let fx equal to 0 to find the value of x. Third, use the second derivative test. If the value is more than 0, then it is minimum. And if the value is less than 0, it is maximum. After following all the steps, we can go to the final step, which is solve the problem.
Problem statement. Consider the function fx is equal to x squared bracket x plus 3. For question A, find the x-intercepts and the y-intercept. Question B, find the intervals where function is increasing or decreasing. Hence, determine the extremum point if any. For question C, find the intervals where function is concave up or concave down. Hence, determine the inflection points if any. Using the above information, sketch the graph of fx. Question A. So, for the first question, we need to determine the x-intercepts and the y-intercept using function the given, which is fx equal to x squared bracket x plus 3. To determine the x-intercept, y must be equal to 0. So, fx equal to 0. 0 equal to x squared bracket x plus 3. Now, split up the equation to find the x-intercepts. First, x squared equal to 0. So, the final answer is x equal to 0. For the second one, x plus 3 equal to 0. So, the final answer is x equal to 3. Next, to determine y-intercept, x must be equal to 0. So, we just need to substitute x equal 0 into the function. The equation will be f0 equal to 0 square bracket 0 plus 3. And the final answer is y-intercept equal to 0.
Next, we will be answering question B, which is that the intervals where the function is increasing or decreasing, hence determine the extreme points, if any. So what do we need to do to solve this question? So the first step is that we need to find the derivative, which is the f prime x. So we take the equation from the question, which is x squared, x plus 3, and we expand it to get f prime x. And the answer will be 3x squared plus 6x. And that's for step 1. And for the next step, which is the step 2, is that we need to let the fx that we just got equal to 0. Why? We need to do this to get the x value. Thus, in the end, you will get two values of x, which is x is equal to 0 and also x is equal to negative 2. After getting the x value, you will need to do the third step, which is the critical line. It will look like this. Next, we need to do the derivative table, which is like this. So, for the first column, we got interval, and for the second column, we got test value, and for the third column, we got sign of f prime x, which is the one that we got from here. The same equation that we used. So the first interval is we got from here, which is the negative infinity and negative 2. The second one is here, negative 2 and 0, which is in between here. And the third one, the third interval is 0 and infinity, which is going there. So for the test value, for the first one, we need to choose a number which is more than negative 2. So here I chose negative 3. For the second test value is we need to find the number between negative 2 and also 0. So in between here. So I chose negative 1 for this test value, and for the last test value is that we need to find a number larger than 0, which is 2. Next is sign of f prime x. How do we get this sign? Is that we put these three test value into this equation. You just need to replace the x with these three test value and you will get the signs. Either it is a positive or a negative. As for the fifth step is that we need to find the correct sign. So for increasing interval, we will choose negative infinity and also negative 2, union 0, infinity. For decreasing interval, we will choose negative 2 and also 0. Why? Because for decreasing, the signs is negative, while for the increasing one is the signs are positive. That's why the both equations are chosen. As for the last step, which is the sixth step, is that we need to determine the extremum points. So here, I have done the calculation below here. So I just put when x is equal to negative 2 and when x is equal to 0, which is the value that we got here. So I replace the x and you will get this number. Thus, the maximum point will be negative 2 and 4. As for the minimum point, is when you replace 0 with x, which is b for this, you will get the minimum point, which is 0, 0.
For question C, the first step, we must double differentiate the function. So, we will get f double prime x equal to 6x plus 6. To find x value, we need to let f double prime x equal to 0. So, we will get x equal to negative 1. The second step is we need to sketch the inflection line. Next step is we need to sketch the second derivative table using the function that we have double differentiate. For interval, we write negative infinity, negative 1 and negative 1, positive infinity. For the test value, x is less than negative, so we choose negative 2. And for x is more than negative 1, we choose 0. For the sign of f double prime x equal to 6x plus 6, we just need to substitute the test value into the equation to get the negative or positive value. We assume that if concave down, it must negative, and for concave up is positive. So, for concave up, it is negative 1, positive infinity, and for concave down, it is negative infinity, negative 1. Step 4. Find the inflection point. To find the inflection point, we must find the value of y using the x value that we got from step 1. So, the inflection point is negative 1, positive 2. And the last step is sketch the graph of fx. So, for the graph, we plotted the minimum and maximum point, inflection points, and the x and y intercept.
To conclude, the derivative of a function can be found using the differentiation method. Mathematicians can utilize differentiation as a potent tool to analyze the behavior of functions, find the rate of change of a function, and solve optimization issues. It is a fundamental idea in calculus and has uses in physics, engineering, and economics, among many other disciplines. Moreover, differentiation is a flexible strategy that may be applied to a range of issues. Anyone who wishes to comprehend how mathematics functions and how it can be used to model the world around us will find it to be a helpful skill.